In this video, I'm going to show you how to use integration by parts to solve calculus problems involving functions that are combinations of sine, cos, or exponential functions. So consider the function f at x is equal to e to the 4x times cos 3x. As you can see, we have a function that is the product of an exponential function and a trigonometric function, a cosine function. So how would we evaluate this integral using integration by parts? Well, we're going to have a table just like we did in the previous videos. So as you can see here, we have a derivatives column and we have an integrals column. So what we're doing here is we're going to take the derivative of e to the power of 4, which is this function right here, and then we're going to take the derivative of this and we're going to get this. On the integral side, we have cosine. So we have a cosine, a cos 3x. And we're going to take the integral of it, which we get sine 3x over 3, and then we take only one more integral, okay? And we get cos 3x over 9. And the reason why we only take one more integral is because we want to get it back to so that it's in the form cos 3x here. And you will see why this is important in just a second. So how would we evaluate this? So what I'm going to do is I'm going to write my minus sign here as in before. I'm going to write my plus sign here as well. And I'm also going to do the same thing in terms of drawing the arrows. So just like before, I'm going to draw my arrows. So I'm going to draw an arrow from from the e to the 4x pointing to the sine function. And I'm going to draw this arrow pointing here. And then I can go ahead and find my integral. So again, the question is asking us to find I, okay, which is the integral of f at x dx, which is this here. So to start integrating this, we have I is equal to, okay, so we'll have e to the power of 4x times sine 3x over 3. So e to the 4x times sine 3x over 3 minus 4 times e to the 4x times negative cos 3x. Okay, minus, okay, minus, we'll go we'll go negative actually because there's negative on the cos there, 4 times e, shall I just put it this way, just so you know where I'm coming from here, x times negative cos 3x divided by 9. Okay, and now this is the next stage. I guess it's a critical stage. So what we're going to do here is we're going to go plus, okay, plus the cosine here. Okay, we're going to multiply this times this here. We're going to multiply negative cos 3x times 9 times 16 times e to the 4x. So we're going to go plus the integral, okay, the integral of this, okay, since we're multiplying this, we're going across, we're going to do the integral of negative 16 over 9 times e to the 4x cos 3x. Okay, now why did I write it like this? So as you can see here, what we're going to do is we're going to do another equality here. Okay, and I'm going to bring this down here, minus, I'm going to bring this term down here, plus, I'm going to bring this negative 16 over 9 out of the integrand. So negative 16 over 9 times e to the 4x cos 3x. Okay, as you can see here, this is now equal to this, okay, our original function. Okay, and as you can see here, I is equal to the integral of f at x dx, okay? That's what I is equal to, the integral of f at x dx. So as you can see here, we can rewrite this as negative 16 over 9I, okay? And the reason why is, again, because I is equal to the integral of e to the 4x cos 3x, okay? And then we have that right here. Again, that's why we stopped here, okay? It's because of this. We would have this, these two multiplied together. So now that we've simplified it, we can rewrite this as I, or negative 16 over 9I. So our function would look like this. It would look like e to the 4x sine 3x over 3, okay, plus, because the two negatives cancel out, plus 4 times e to the power 4x cos 3x over 9 minus 16 over 9I. So minus 16 over 9I. Okay, as you can see, we have I here too, which is great because what we can do now is we can add 16 over 9 I to both sides. So we can bring this 16 over 9 I to this side, and this is what we would get. We get I plus 16 over 9I, 16 over 9I is equal to this expression here. Okay, e to the 4x sine 3x over 3 plus 4 times e to the 4x cos 3x over 9. Okay, and now what we can do is we can add I to 16 over 9I, and when we get that, okay, when we do the addition, so we have 9 over 9 plus 16 over 9, and that'll give us 25 over 9. So here we get 25 over 9I. Okay, so we can scroll down here, create a little bit more space, is equal to all this. So what we can do now, okay, we're going to bring this down here, of course, is we can multiply both sides by 9 over 25. Okay, so we'll multiply by 9, divide by 25, so 9 over 25, and we'll get this 9 over 25 times e to the 4x sine 3x over 3 plus, okay, plus 4 over 9, 4 over, or sorry, I'll just go 4 times e to the 4x cos 3x over 9 plus c. And this is the integral to that function. Okay, so yeah, there you have it. That is the integral to f of x is equal to e to the 4x cos 3x, just like that. Of course, you can simplify this even further if you wanted to. You can take out the 3, and you can also factor out the e to the 4x, but we're just going to leave it in this form here.